We are given an array and we need to find the smallest subarray after removing of which our array is sorted. So for example, in this case, let's say we have this array and the smallest subarray that we can remove in order to make our whole array to be sorted is this part, right? If we remove 10, 4, and 2 with the size of 3, so with the size of 3, then this array will be sorted. So how we are going to approach to solve this problem? The way we do that is first step, right? The first step, we find what is the sorted prefix here. The sorted prefix here is 1, 2, 3, 4. This part of the array is sorted. And what is the sorted suffix here, which means that at the second part of the array, right, starting from the end. So what is the sorted prefix? In this case, 2, 3, and the 5 is sorted. So we find these 2 points, prefix and the suffix, which are sorted. So the first step that we are going to assume is, so we have sorted prefix, we have sorted the suffix, and if we remove the rest of the array, then as a subarray, then our array will be sorted. So in this case, if we keep this part of the array and remove the rest, which is the size of 4, our array will be sorted. If we keep this part and remove this part, then in that case again our array will be sorted. So what we do is we are finding the shortest subarray. We are finding the shortest subarray that we need to remove. In this case, the shortest subarray is this one. So initially we are removing the array with the size of 4. So that's the first step. So we find the suffix and the prefix, then we are taking the shortest one that we can remove, and after that we are returning that result. That's the first step. What's the second step? Can we do better than this result, right? Can we do better than 4? So for that, let's try to merge prefix and the suffix here and see that can we go to the better result. So for that, let's keep here 2 pointers, I pointer and the j pointer. I pointer is pointing to the index from the very beginning, right, for the 0 index, and the j pointer is pointing to the first index of the sorted suffix, and we try to merge these 2 parts. We are comparing the first index of I and the first index of the prefix and the first index of the suffix, and the value under the first index of the prefix should always be less than or equal to the value of the suffix. So for example, in this case, 1 is less than 2, so what we do is we are moving this index here, right? Now if we remove this part of the subarray from 2 to 4, this array will be sorted, right? So the value is the size of this subarray is still 4, so we are keeping 4 here. Again, we are comparing 2 and the 2. 2 is equals to 2, and we are moving our I pointer here. Now we can remove this part of the subarray, right? If we remove this part of the subarray starting from 3 to 4, then this array still will be sorted, and the value of this subarray, the size of this subarray is equals to 3, so we are updating the value, right? We are updating the size of the subarray that we need to remove. So this is better result. Now let's go explore and see that do we have better result or not. So now what we do is we are comparing 3 again with the 2, and the 3 is not 3 is more than 2, so now we are moving our j pointer. We are moving our j pointer, and so again we are comparing 3 and 3. 3 is equals to 3, we are moving our I pointer, so which means that now starting from here to here, right, if we remove this subarray, again the rest of the array will be sorted, but the size is still equals to 3, and we are not updating our value. And then we are moving our j pointer until the end, so we don't have any result where our size of our subarray is less than 3, so we are returning 3 in this case. And for the example of let's say we have only increasing array, right, non-decreasing array, in this case we are returning 0 because we are not removing any subarray here, and in this case we have a decreasing array and in this case we are just removing, we can keep the one element and we should remove the rest of the elements from the array. As a solution wise, as we have seen earlier, so what we do, right, so first we are finding a prefix, so we are defining our left, and the left starts from the 0, and we are checking that if the previous value, if the value at the left is less than or equal to the left plus 1, right, to the next value. So if we are returning, if the left is at the end is equals to the n minus 1, which means that the size of the array, it means that the array is already sorted. We are returning the value already 0, right? So we don't need to remove any subarray. And the second step, we are finding a suffix, right? The same thing that we did with here with the starting from the left. Now we are starting from the right, and we are doing exactly the same. We are comparing the value and finding the suffix. And after that, so what we do, we are removing either right side of the array or left side of the array, and we are taking that as a result. And then we try to improve our result that we have seen, as we have seen earlier, right? So we are defining two values here. We are defining that the first value, right, starting from the prefix start from the index 0, and the suffix start from the value of the whatever the right has reached here, right? So the j starts from that point. So at each point we are comparing that. If the value of the prefix is less than or equal to the value of the suffix, then in that case what we do is we are taking the minimum value, whatever is the minimum, right? Either result or j minus I. So whichever is the minimum, so we are taking that value and we are moving our I pointer. Otherwise we are moving our j pointer, and at the end we are returning result.